Hi everyone, my name's Brooke and today I'm going to show you how I figured out an unknown compound using 4 different sets of spectra. So the first set of data I used was an IR. So here's the IR for the unknown that I'm trying to figure out. So the first thing I notice is the small peaks at 3000, which tells me that there is a CH stretch, either from an alkene or an aromatic. The next thing that sticks out to me is the peak at 1509, which tells me that there is a CC stretch, specifically an N-ring stretch. So we know we have an aromatic present in the compound. And the next and final peak that I see is at 1243, strong peak, and that tells me that I have a CO stretch, specifically for an ether. So an IR's job is to tell us the functional groups in our compound. So did the job, told us that we have an ether. So the next thing that we're going to look at is the mass spec. So lucky for us, we do have an N plus peak, so this is going to tell us that the molecular weight of our compound is 148. So we know that we have an oxygen from the IR, so what we did over here is we're going to use the rule of 13. So 148, subtract the molecular weight of oxygen, 132, divided by 13 is 10 with a remainder of 2. So this tells us that we have 10 carbons, 12 hydrogens, and 1 oxygen, which is going to be our molecular formula, unless proven otherwise. So the next thing that stands out to me is the peak at 77, which basically means that we have a benzene ring. So this is the fragment that I'm drawing over to the right, is the fragment that the peak at 77 shows us. And then the next thing, if we want to show that we do have an ether, this fragment over here has a molecular weight of 31. So 148, our molecular ion, minus 31 is 117, and believe it or not, we do have a peak at 117, so we do have an ether. The next thing we're going to do is find the degrees of freedom, which tells us how many double bonds or how many rings are in our compound. So for this compound, the degrees of freedom is the number of carbons, 10 times 2, plus 2, minus the number of hydrogens, which is 12, all divided by 2, which gives us degrees of freedom of 5, which means we have 5 and or double bonds or rings. So this was the first half of the video. In the next half of the video, I will describe a carbon and hydrogen NMR to go along with these two. Thanks for watching.